We saw how to differentiate the inverse trig. Now we're not going to integrate inverse trig now, that's something we'll leave for extension 2. This is integration that involves inverse trig, in other words going back the other way. If we see dx over the square root of a squared minus x squared, that must go back to the inverse sine of x on a. The interesting thing with this though is we have a choice. It could also have been minus the inverse cos. So you could choose which one you use. Later, when we start looking at simple harmonic motion, there'll be good reasons why we would go for minus inverse cos rather than inverse sine. So it just depends on the question which one you might end up using. The other one's straightforward. Dx on a squared plus x squared, there's only one thing it can go to, is inverse tan. But we've got to be careful with that one, because remember how we got a on a squared plus x squared? So with inverse tan, you need to go 1 on a out the front. Again, I find it handier to say, let's set the integral up to what we're used to seeing. So if I have f dash x over the square root of, but instead of putting 1 there, you'll notice I've put a squared. This makes life really easy when we do it. So if you've got f dash x over the square root of a squared minus the function squared. So it could be any number minus the function squared. But the key we're looking for is the function squared and the derivative on top. That's what we're looking for. It'll end up being the inverse sine of the function divided by a. So of course normally when I would have had it as 1 minus function x squared, a was 1. So we had just function x. But if we remember that a squared trick, that can save a bit of time. Or again, you could go minus the inverse cos. Now, with tan, or inverse tan I should say, so with inverse tan, again, we've just got to remember the 1 on a out the front when we're dealing with inverse tan. So there's a simple little one, dx on the square root of 4 minus x squared. So I know that will be the inverse sine of x on 2, plus of course a constant. Dx on 9 plus x squared will be a third of inverse tan x on 3. Let's do a definite one. Dx on the square root of 2 minus x squared will get inverse sine of x on root 2. Substitute in the 1, substitute in 0. And you'll see these sort of numbers come up a lot because of course they're our exact values. The inverse sine of 1 on root 2. Now the answer has to be in radians. It would be incorrect to say the value of that integral is 45. It's not. It's pi on 4. We're talking a number. So if you're saying the area under the curve, well, it's pi on 4 units. So if you're at 45, that would just be wrong. Clearly that would be a bigger area. So this is where we must use radians. Anytime you see trig and calculus, just use radians. Avoids any mistakes. Differentiate inverse sine of e to the x and hence go and evaluate. So this is one of these ones where if we don't have a clue, we can probably guess what the answer is going to be, or be something to do with this, because the and hence is kind of telling us, oh well, integrate, we go backwards. And in fact, when we differentiate, we actually do get e to the power of x on the square root of 1 minus e to the x, derivative over square root 1 minus the function. Therefore, when we integrate, we must get inverse sine e to the x. We're going from minus log 2 to 0. So sum in 0, e to the power of 0 becomes 1. E to the minus log 2. So the negative comes inside the log, and we now have log 2 to the power of negative 1. But now we've got e to the power of log, that'll cancel. So we get 2 to the negative 1, which is of course a half. So we've got inverse sine of a half there. Pi on 2 minus pi on 6 gives us pi on 3. Well, what I would like is the derivative on top. Derivative of what? Remember, it's not the derivative of 9x squared, because that's the function squared. So the actual function we're looking for there is 3x. Derivative of 3x would be 3. So all right, let's put 3 on top, but to balance it out, I need a third out the front. It's now in the form I like, so I know it'll be the inverse sine of function x, 3x, over a. Remember, 4 is a squared. So over 2. That'll do us.